Okay, so welcome back to lesson 7 or unit 7. This is going to be lesson 2, looking at again bringing in those transformations from way back at the beginning of the course and applying them to our exponential functions. Now that we know what an exponential function is, so I'm going to draw your attention to these letters that we have here. In terms of C and D, we're going to change these letters around a little bit. I was looking at them and I don't like them just based on how we were using the same letters before. So I'm going to change my base to N. So I'm just going to cross this out and rewrite it. So I'm going to write it as Y minus D equals A N. That N is going to be my base, so I'm just going to make it kind of bold so that I remember that it's not actually representing anything, to the power of B X minus C. Okay, and so these letters are now going to match much better with what we talked about before. And so in terms of changing these, it's A causes our vertical stretch or compression. B, just like before, causes our horizontal stretch and compression. D is our vertical translation, and you'll remember that we actually wrote it over here as plus D. Either notation is totally fine with me. You'll just see it more often on this side in this particular case. And C, I'm just going to cross this out. C here will be the horizontal translation. And again, you'll notice it's the opposite sign. In terms of these guys then, it is B that causes our reflection over Y, and A that causes our reflection over X. So this is consistent now. Sorry about all those changes, but make those changes now, and then we can talk more consistently with our unit that we previously did on transformations. So when we look at this first example, the thing I notice is that we've got this plus 1. So I don't really care about my base. My base just strictly is a note to myself that when I have a fraction there, it's going this way, okay? So just kind of as use a different color. I'm expecting that shape, okay? Plus 1, again, is going to be my horizontal because I'm impacting my X. It's inside that function. And it's going to be a shift. And specifically, it's going to be a shift to the, if you remember opposite signs, we do the opposite. So left. Okay, so instead of working with the axes that we actually have, what I'm going to do is I'm going to imagine that there is an axis right here. And I'll erase that after, but just kind of as a reference point. My axis, my imaginary y-axis is over here. And so my y-intercept, which it's supposed to be at 1, is actually going to show up over here at x equals 1. Negative 1, sorry. And so my y-intercept is not 1. And this is a weird situation where we start messing around with those rules that we saw in the previous lesson, because when I plug in 0 for x here, I'm actually having an exponent of 1. And so my value is going to be a third. So if you want to make a table of values, you totally can do that. There's nothing wrong with that. But I'm going to go to negative 2, negative 1, 0, and 1. So when I plug this in, negative 2 plus 1 is just 1. So it's 1/3 the power of 1, which equals a third. Here, it's going to be the power of 0. So that's 1. And then, sorry, negative 1, so it's 3. Having issues with these guys today. To the power of 0, that makes it to the power of 1. And this becomes the power of 2, so 1/9. So Why is our axis lined up like this? Well, because we needed to remember that our graph is going to be increasing very steeply over here. So we don't need a lot of space on the left, even though we've shifted left. And then on the right, it drags out forever. I'm not actually going to show it dragging out forever because I'm going to run the risk of accidentally crossing my x-axis. But remember also to label your asymptote of y equals 0 there. And now I can graph this. Okay, so if that imaginary axis helps you place your shape, oops. Go ahead and do that. There we go. That's my function. So it is decreasing. And that's determined by our base between 0 and 1. The intercepts, again, there's no x-intercept, but the y-intercept is at 1/3. So again, this is a change because of the shift. My asymptote has not changed because I didn't move it vertically at all. So my domain, I'm allowed to put anything in my exponent still. That hasn't changed, so that's nice. And my range also hasn't changed because I'm still above my x-axis, my horizontal asymptote being at y equals 0. So the only change is that y-intercept. Okay, so that's the only thing that shifts with the horizontal shift. Okay, and you don't need to leave that line there. That's what it should look like, really. So, what about this one? Well, I know that because my base is greater than 1, I'm going to expect my graph to look like this. I know that this piece here, again, is going to be shift left. Okay. And then this piece here means that I'm reflecting, but I'm not reflecting horizontally, I'm reflecting vertically over my x-axis, which means that I'm going to draw it actually below my x-axis. So instead of it looking like this, it's going to look like this to some degree. So all of that information I get from my equation. Now I just need to kind of make sure that I don't screw it up like I did the last one. So again, choose some values going on either side. So I'm going to go to -2 just because I know I've shifted left 1. So to -1, 0, 1. So I'm going to use the same values as before. I'm going to go -3 to the power of -2 plus 1 gives me, so that's +1, 3, but it's -3. At that point, you're going to pause me and say, Miss Conrad, no, it's not -3, it's -1/3 because -2 plus 1 is -1. Get your act together, Miss Conrad. Okay, so -1/3, -1. And so the key thing is that in order for this to be true and for this to work always, that negative needs to be outside of the brackets. That's why we had that very specific stipulation that the base had to be positive, had to be greater than 0. Because if that negative's in here, then even if I have it to the power of 0, it ends up being +1. And we don't want that because then we got some weird point floating up here while the rest of my graph is down below. So that's a bad idea. Instead, that negative out in front is going to give us that consistency and always staying below the x-axis. So what we see is, this is going to be a pretty ugly one. I apologize in advance. This grid is not very nice to work on. -1, -2. 2, y-axis, x-axis. Y equals 0 is still my asymptote, because you'll notice, again, I didn't go onto the other side. I'm not going to end up positive somehow. So when I graph this, -2 and a third, -1 and -1, 0 and -3, and by the time I get over here, I'm like way down below my graph. So again, these axes are not really conducive to this example, so I apologize for that. Okay, but that would be the general shape of my graph. So again, it matches my prediction. So it's always good to predict and use those transformation pieces as much as possible so that we feel as confident as we can in answering these questions and drawing our graphs. In this case, because even though it should be increasing because it's above our axis, because it's below reading left to right, it is decreasing. Intercepts, again, still no x-intercept, but our y-intercept is now at y equals -3. Equations of any asymptotes or horizontal asymptote is at y equals 0. Domain of the function still allowed anything in that exponent place, so that's nice. But our range changes a little bit here with that reflection because we're going down to infinity and we max out at 0 at a horizontal asymptote. Okay, so that's the impact of that reflection. It's just it flips that upside down, and any values that we would have had have to flip too. If you're feeling brave, give example 3 a shot on your own. I'm going to reattempt this, not drawing a table of values and figuring out numbers thing. So I am seeing, these are all kind of my notes of transformation. So 2 would have originally given me this increasing graph, but this horizontal reflection is the equivalent to having a fraction in the denominator, as we said in our last lesson. So it's actually going to end up being a decreasing function. My shift is now to the right one because I've changed the sign to negative. And then that 3 that's out in front is actually going to be a vertical stretch. So that's also kind of interesting. So what does that look like? Well, shifting my imaginary axis over 1 to x equals 1. And my y-axis, I'm going to make a little smaller because of that vertical stretch. 3, 4, 5, 6, 7, 8, 9, 10. -1 and -1. Okay, so what I'm expecting now is my quote-unquote y-intercept should have originally been at 1, but then I shifted it over 1 and I'm stretching it by 3. Okay, so that's kind of the big one. You can plug in values and use your brain. So it would be 2 to the power of 1 is 2 times 3 is 6, and that's what's going to happen here. 2 to the power of -1 would be a half, so half times 3 is 1 1/2. That gets us here. So we're farther away from our horizontal asymptote. So we're going to get that more gradual kind of slope in comparison down here, but it also means we're going to get steeper much faster. And that's the impact of that vertical stretch by 3, is that it kind of stretches us out vertically, which allows a more gradual slope and along here. Making sure that that graph is not actually touching our horizontal asymptote. So if I wanted to keep going, this point here would be like 3 minus 1 is 2, but negative, so a fourth times 3, so 3/4. And that looks roughly like where it is. So I'm feeling pretty good about my graph. Ignoring that imaginary horizontal asymptote or vertical axis that I've drawn in there for myself. So we should end up with a graph that looks like this. Again, determining these kind of descriptors, we've got decreasing. I'm just going to circle it. intercepts. We've got a y-intercept at y equals 6. So that's significantly different from the one that we're usually dealing with. The equations of any asymptotes. We've got our horizontal asymptote at 0. I've got that labeled on my graph, double check. Still allowed to put in anything in my exponent though. And my range, because I'm back up above my x-axis again, it starts at 0 and extends upward. So there we go. How'd you do? Pretty good. Hope you're feeling good about this. Try this one. So again, if you like the d value being over here, just a quick note to yourself that it is supposed to be subtracting. If we go back to the beginning of the lesson, you'll see it's minus d, and so it's going to have a similar impact to opposite signs here. If it makes more sense to you, because we did it in our transformation unit, we wrote it as AF B x minus c plus d, and we used, oops, not plus 9, plus d, and we used it so that it had the same sign. You're more than welcome to rearrange that, and that's honestly my personal preference, is having everything on that right hand side. Once I've rearranged it, then I can do whatever I want in terms of labeling and predicting. So that's what I'm going to do. So again, I recommend you pause the video now so that you can try this on your own. Okay, so I've labeled what I expect. I expect this shape like this, right 2, down 1. So I've shifted my horizontal asymptote. I've shifted my imaginary axis that I've drawn in there. So once I've got that set up, I can go back to my original shape. Now I would expect that my y-intercept should be at 1, but I'm going to move it right 2 and down 1. So it should be originally here, so I'm going to move right 2 and down 1. You'll notice that for this graph, because of that vertical shift downward, I am going to have a y-intercept here. Okay, it's also going to impact my range. So it's these vertical and horizontal shifts that are going to have and specifically the vertical shift, that's going to have the greatest impact on those different properties that we look at when we look at them for this function. Okay. From there, everything else should be relatively predictable. So it should have got my original parent function, which would have been 2 to the power of x, should have been 1 and 2. So I'm just going to shift that over 2, down 1, and so make sure I have my y-axis also labeled with some values in here. 2 to the power of 2 would have been 4, shifted over 2, down 1, gets me here. Okay, and these values should be in my half. It should be halfway down, and then about a quarter there, so 3/4, and going from there. And again, you're totally welcome to make a table of values. That's a little ugly. And there we go. So that would be my graph. And again, get rid of that y-axis, imaginary y-axis, if you're using that as a strategy. Whether the function is increasing or decreasing, as it should be with a base that's greater than 1, it is increasing. The x-intercepts and y-intercepts, now we have both because of that vertical shift. So my y-intercept, if I plug in 0 here, I can get the exact value, and so that would be 0 minus 2 is -2, so it would be 1/4, but subtracting 1 would be y equals -3/4. Okay, and then I would have an x-intercept, and again, I've evaluated that, and I figured it out from shifting things around using my transformations at x equals 2. Equations of any asymptotes. I still don't have a vertical asymptote because I haven't changed my domain at all. So my horizontal asymptote is the only one that exists. But again, I've shifted that down 1 due to that vertical shift. So it's now at y equals -1 instead of 0. My domain still allowed to put anything in for x in that exponent, so it's still -infinity to positive infinity. But again, because I've shifted down and my horizontal asymptote has moved down, my range has also moved down to -1 and positive infinity. Okay, so I believe this is our last example here. So again, if you haven't tried one of these on your own at all yet, I do strongly recommend you do that. And in terms of handling this one, it's going to be very similar, but watch out for some very teeny tiny nuances. But give it a shot on your own. So before I start graphing, just a couple of notes. I rewrote the equation so that I could factor out that negative, because just like in our fx notation where we put the b in front of x outside of the brackets, I want that same kind of impact here. So that's why I factored out that negative. So in terms of accomplishing this graph, that's what you're going to want to do first. Because I have my equation written like this though, I am able to do everything all at once. So again, that shift 2 to the right allows me to imagine that asymptote or that vertical axis being here. Okay, I know that instead of being here, we've got that reflection happening in my y-axis, so we're gonna kind of look in this direction instead, and that's again that horizontal reflection, and then that vertical stretch by 3. So making sure that I've got my scale in here so that I know where that axis is supposed to be. 1, vertically, I'm gonna go up by 2, strictly for the purpose of being able to sketch in my curve and knowing that it is stretched vertically. So whereas typically we expect that point to be crossing our quote-unquote axis at 1, because we've shifted it over, we're going to be over here on that imaginary axis I sketched in, and we're going to multiply 1 by 3. So it's going to be up here at 3. From here, if you want to plug in values, help yourself. If you want to try and like reason it out, whatever way makes the most sense for you. If I start plugging in values, I've got 1 minus 2 is -1, but I've got a negative out here, so +1. So that's going to be 2 times 3 is 6. So that's that point here. 0 would get me +2, so that's 4 times 3 is 12. So that's already off my graph, but I'm going to remember that anyways. Because I know I'm going to be asked about intercepts down there. Okay, I have no vertical shift, so I'm expecting my horizontal axis or horizontal asymptote to still be the same at y equals 0. Okay, but plugging in these values, plugging in 3 here, 3 minus 2 is 1, but it's negative. So we've got a half times 3 is 1.5, roughly here. Okay, 4 minus 2 is 2. So -1/4 times 3, it's like 3/4. So we've got that general shape where we're extending like really, really high up here. So in terms of getting my incline, got that piece there. I'm going to encroach upon my x-axis. So for filling in these properties, because of that horizontal reflection, this is decreasing. My intercepts, again, horizontal asymptote prevents any x-intercepts, but my y-intercept I solved for up here, that's why I wrote it down, is going to be y equals 12. Okay, asymptote, again, horizontal asymptote at y equals 0. Domain, no restrictions on what I put in my exponent, but my graph must be, not square brackets, round bracket, 0 above 0. So that's example 5. That's the end of our lesson. So I'm going to be posting some homework for you to practice this idea on, applying the idea of shapes and transformations to our exponential graphs, because I'm pretty sure, I'm pretty confident that you'll have some sort of exponential question. It might not be that you actually have to graph the whole function. It's usually a polynomial question on graphing. But you might need to interpret the graph or explain the transformations. And so we need to be comfortable with this idea of using these exponential graphs that are new this year.